The Missing Operators project from the YByte Python curriculum, available at www.ybyte.in, is an interesting activity where we ask our user to tell us some numbers and ask questions based on that number. For example, 12-32 is minus 20. Now the answer here has to be minus. And then we go on to ask one more question, which is of 3 digits. Now in this case, I guess the answer is minus and minus. And then the game stops. But here I'm looking at an enhancement. Let's say I want questions which are longer than 3 digits. For example, here I asked a question which has got 6 numbers. So 80, 100, 92, and so on and so forth. Now, even with plus and minus, in fact, this can get quite challenging because we have to look at a lot of combinations to solve this. But simplifying my job, I have put the answer here already. So I know the answer is minus, minus, plus, plus, minus. If I give this answer, notice my program tells me well done. And that's not a surprise because if I did 80 minus 100 minus 92, say plus 12 plus 88 minus 68, indeed the answer is minus 80. Of course, since I know the answer, it's easy for me, but solving it without knowing the answer is actually quite hard. We can take one more example. Let's say I say, so I do this again. Say I say 12, 32, say this is multiply. In this case is, well, so plus and minus. Now a long question. So if I answer yes, again, it has asked me a long question, 29, 16, lots of numbers, 6 numbers there. I know the answer is minus, plus, minus, 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 but let's say I make a mistake intentionally. This guy catches me, it says, nope, sorry, that was incorrect. So in this video, we'll see how we can generate these kind of long questions in a systematic step-by-step manner. Before I get on with this, let us first define what do I mean by a long question. Well, since the class project already deals with, let's say, up to 3 numbers, or hence 2 operators, let's say any question which has got 3 or more operators, which means at least 4 numbers, would be seen as a long question. So for example, it could be 1 2 3 4, 1 dash 2 dash 3 dash 4, and so on and so forth. So 4 numbers here, 5 numbers, 6 numbers. Now each of these will be classified as a long question. Now it turns out that the process to generate this is no different from what we were doing from, let's say, 2 or 3 numbers, but just that because of the larger, because of the more numbers here, we have to be a little bit more systematic. In fact, we have identified 5 steps that we are going to do. First thing, we are going to generate and store the numbers. We are going to generate and store the operators, and clearly number of operators is 1 less than the number of numbers. We are going to generate the correct answer. Now this is usually the trickiest part because we have to figure out how to compute this. Next, we are going to frame the question that is to be asked because the user must be asked a very clean question. And finally, we must evaluate the user's response for the correctness. Now, like I said, these steps are no different from what was happening in the smaller questions. It's just that with the larger number of numbers, it turns out that using lists and loops greatly simplifies these steps, make it highly scalable. So you can use this approach even for, let's say, 2 numbers or say even 20 numbers, right? So, this is what we are going to discuss in this video. Let's move through step by step. The first thing that I'm going to do is to store and generate these numbers and operators. So the way I do that is I'm going to, randomly generate these numbers and operators. So I define how many numbers do I need, and I create 2 lists, list numbers, list ops, in which I keep appending, say, random numbers and random operators. Now notice here, I'm choosing operators also from the op list, which I defined previously, and I'm picking only 0 and 1 because I want only addition and subtraction for now. Yeah. Also notice that we have 1 operator less than numbers because if you have 6 numbers, then we have 5 operators, and that's why in this for loop over here, I'm using the range n numbers and range n numbers minus 1. Let's see this working first. Let's get on. Let's write this little bit of code. So I come in here. I just enhance my previous game. So I just say, for example, print, and I say print. Let's say, now a long question, right? And now I need to, like I said, generate those numbers. So I say, for example, n numbers is equal to say 6. Now I can change this to 6, 7, 8, whatever I want. Generate any number. Like I said, I'm going to create 2 lists over here. So I'm going to create first one, the list of, let's say list, let's say numbers, and as an empty list. I'm going to also create a list of, let's say, ops as an empty list. And I'm going to just populate these two using a for loop. So I say for kk in range, for example, n numbers, which is basically saying that generate 6 numbers for me. It's like a for loop is here is being like a repeat loop. And I just say, all right, list numbers, say dot append, And what do I append? Well, I just take a random number between, let's say, random dot rand int, say 1 and 100. Um, and yeah, that's about it. And I need to do the same thing for the operators, but I just have to be a little bit careful that I'll be generating one lesser operator, and hence I do range n numbers minus 1. Also, in this case, I'll be updating list ops, and I'll be picking up operators from the op list. Now remember, op list has been defined previously. So I just pick up a random element from that list, and my op list has three elements, 0, 1, and 2. We can see this fact earlier up here. So if I were to look at, say, op list, it is plus, minus, and multiply. That's why I'm just picking up either 1, either 0 or 1, and that I'm doing through this random operator. Now with this done, if I were to print, let's say, list numbers, and let's say print, say, list, say, ops. Now I should be able to see these numbers that I've selected and so on. So I say, for example, so I just run through this quickly. Multiply, say, let's say minus minus. Now it has picked up six numbers: 56, 2, 44, 34, 11, and 82, and it has picked up five operators. Now these are my two lists. It's quite handy, as I develop this, because I can test my solution later on. Yeah. So the first two steps are over. I've generated the numbers and generated the operators. Clearly, if you want to generate more, you can change this. You want to generate less, also you can change this, right? So you can even use the same approach for, say, two numbers. Moving forward, I need to, generate the RHS, right? Now it turns out that there are two approaches for this. One is using the eval statement, which turns out simpler, especially when we have operators with multiple precedences, like, higher precedence, lower precedence, and so on. But we will look at this in a separate video. What I'm going to look at here is using lists and loop and just logic. How do we create the RHS? And this is, in fact, a very good programming practice. So that's why it's interesting to look at it. Really what we are doing is that we have the list of numbers, list of operators. So I just go through this list of operators, and I check if the list of ops is a plus, I just add to the result. Otherwise I subtract. Now in fact, if you think about it, this is exactly what was going on earlier when we had this num1 num2. We are doing num1 plus num2, and you say num1 plus num2 minus num3, and so on and so forth. That exact same thing was happening here. It's just that with these lists it becomes a little bit more concise. So let's just do that here. I come in here and I say, look, I'm going to generate, let's just put a, let's say, a small print comment here, generate RHS. And the way I do that is I just define a variable called RHS. I assign it to the first number because that's reasonable. I just say, okay, look, I'm going to start with that, no matter whether it's plus minus, because that number is always taken as a starting point. And I say for kk in range. Now I must do this for the number of operators that I have, because so I just say list, say, ops. So for the kk in range list ops, I will, just check if that particular operator is a plus or a minus. So I go and check list ops, say kk is equal to, for example, plus. Now, if this is the case, I must go and update my RHS by adding, plus list, say, numbers kk plus 1. Now please pay attention to this indices here. Remember, we are starting kk at 0 because that's the range function. So when I see this range, if I see the first operator is, let's say, plus, then what I really want to do is to add the first two numbers, which means I'm going to add list numbers 0 plus list numbers 1, and that's exactly what will happen. My RHS starts being list number 0, and I just go and add to that list numbers 1. A little bit of thought is required here, but it's not too hard. And finally, if I say, if, let's say, or I can just put an else, that's fine too. I can just say list, say, ops kk is equal to, let's say, a minus sign. Then I compute RHS by saying RHS minus list, say, numbers, and again kk plus 1. Now really this is not hard. All I need to do really is to go through this entire list, and at this point we can print our kk, and we can just not kk, sorry, we can print our RHS, right? So let's see this working first. So if I were to do this, again, I run through the first few questions quite fast. So I'd say, for example, plus here. um, this is probably, let's say, whatever. So now I've got a long question with these operators. Let's just verify. 86 plus 9 minus 20 minus 99 plus 19 plus 90, that is indeed equal to 85. And that's how I've computed, because really, the logic is not hard. And like I said, if you think about it, what we are doing here is a little bit more concise version of what we had done earlier. Previously also we had picked up two operators randomly. Previously also we had been building up their RHS by going through the numbers one by one. It's just that now this approach is a lot more scalable. Now at this point, I do want to highlight that be very careful about the lists. The op list that we had used here is the number of operators in the game. That's why we picked up from there. Whereas the list of ops is the list of operators for this particular question. And with that, I think they should be pretty clear. Now, the next step would be to frame a question that I can ask the user. Now, previously, remember, we are using the input statement for this. We'll in fact do the exact same thing. But, and we know that input requires just one string to be given. The challenge here really is that we now need to create a fairly complicated string. It turns out that using a for loop, this job simplifies. So what I'm going to do is that I'm going to first create this string called question, and then I'm going to add that. And the way I'm going to create the question is actually quite simple, quite logical. Basically, I'll just go through all the numbers. For the first few numbers, I just keep adding question plus, let's say, number and a dash. Number and a dash. And for the very last number, which is, notice, n numbers, kk is going from 0 to n numbers minus 1. So if kk is less than equal to n numbers minus 2, I'm not at the last number, and I keep doing this. Else I go and complete the question for the last number. Now again, this is logical, and we can see this working. So let's just get to a code here. I go and say, look, so RHS is printed, that's okay. I'm going to say, let us frame the question. So the way I do that is, by saying that I'm going to, just give me a moment. Yeah. So I'm just going to print, let's say print a statement over here. Let's say one empty print, and I just say print, for example, can you tell the, say, the missing operators? And again, this is only, say, plus and minus. I mean, for now at least, it's only plus and minus. Now I need to form the question, so I just define a string to be an empty string. I just say for kk in range, let's say n numbers. Now notice here I'm doing for the numbers. I'm going to go from, go through every number, and I just keep printing if kk, so kk is my counting variable here. So I just say kk, if kk is less than n numbers minus 2, which means I'm looking at not the last number, but the numbers before that. What I do here is qn is equal to qn plus, let's say I convert this numbers to a string. So str, say list numbers kk, and at the end of this I must put a dash, because the question is still being formed. The moment I reach the last number, which is the else situation, I must close the question. So I go and say question is equal to qn plus, str, let's say list numbers, say kk, and plus, because now I must close this question, so I must put equals and plus str, let's say RHS. Now notice here that the plus operator is being used for strings in this line, which means it's going to work like a join apple banana, or say a concatenation, in more formal words, right? So I'm just going to be building up the string, and in fact at the end of this I can ask, I can just ask answer is equal to, say, input, say qn. Now in order to just sort of understand this working, let us put a print over here. Notice this print is inside the for loop, so it's going to print for every iteration. I'm going to print this qn, and it's quite illustrative because we can see this thing forming. So I say, for example, 12, say 32, say plus here, say this is plus and minus. Now notice what's going on here, right? So I picked up this list 43, 85, 52, and so on and so forth. My question string was formed bit by bit. So first number plus dash, first number dash, second number dash, and so on and so forth till I reach the last number. And I then completed the question by saying equals to, and 89, which is RHS. Like I said, these are all addition happening on a string, which means they are all acting like joining the string. So that's why I'm getting the string. And now finally I can just ask my answer, input to question. In fact, I can, I'm kind of ready to take my answer here, right? So I can just use input question here. I can remove this line, and we are done with this step. The last step, which is to check the correct answer. The idea is really the same as earlier. Like I said, if we had two operators, we had to make sure both of these were correct. Now, in this case, we have more operators. We just have to make sure each of these is correct. Again, to make this efficient, we can use a for loop. So what I can check is, for kk in range n numbers minus 1, because that's the number of operators that I have. If my answer kk is equal to list ops kk. Now remember, list ops is the list of operators for that question. So all I'm checking is that every answer that has been provided, elements by element, matches to the list of operators. If that happens, that's good. If that does not happen, now this is very interesting. If let's say I do not see an equality, I know something has gone wrong, because each one of them had to match. Now the first, there's one which is not matching. I know something is wrong. I just say incorrect, and at this point I use a break statement to break out of this loop, because I don't need to test further. On the other hand, if I never come into this and I keep going into this, if kk is equal to n numbers minus 2, now again, don't get confused here. Kk is going from 0, 1, 2, 3, 4 to n numbers to n numbers minus 2. So if I'm at the last number, then I say, all right, look, you must have done very well, and it's all correct, because it means that every element of the answer is matching to the list of ops. Right? So let's just see this working again. I come in here. So I just say, for example, let's say checking the answer, and the way I do that is for kk in range, let's say n numbers minus 1. And again, I just go and check if answer, because remember, answer is what user is providing to me. That's a string, so I can index into it. So I say answer kk is equal to list ops, let's say kk. So if the two match, then I just check another condition. I say if kk is equal to, let's say, n numbers minus 2. Now again, a little bit confusing, but basically saying that I'm checking every operator. I keep checking this until the last operator is reached. If the last operator still holds this true, this still holds true, then I can say, well, everything is right. I can print, say, well done over here. And on the other hand, else, if this doesn't happen, so again, this else has to be aligned with kk. So notice, see the indentation here. It has to be aligned with answer equals to kk. So I'll say else. I'm sorry, it has to be aligned with this. Else has to be aligned with answer kk is equal to list stops kk. If this doesn't happen, it means something has gone wrong. I don't need to check further. I just say print nope. Say nope, incorrect. And okay, I need to put this under. Sorry, my bad here. So I can just say print nope, incorrect, and I can just break from the loop. Now again, this is not different from what we are doing. It's just a little bit more concise. Let's see this working. So let's see the correct answer first. I go and check, for example, 12, say 44. So plus here, again, this is, I guess, plus and plus. Now a long question. The answer is, I know, is minus plus 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 plus. Now I know this because I'm writing the answer over here. That was a list of operators. If I give this answer, indeed I get a well done. And that's because if you look at my kk is equal to 4. Because remember, kk went from 0, 1, 2, 3, 4. It went and checked every operator over here. And it found that, yes, this is matching. The answer, first operator is matching to the second list of operators, and so on and so forth. Once it reached the fourth, it said, okay, well done, because everything is all. See, on the other hand, let's say I make a mistake here. They're all plus, but let's say I go and put minus plus plus plus. It says nope, incorrect. The interesting bit is kk is 0, because at the very first iteration, remember, kk goes from 0. Answer 0 is not equal to the list of 0. The first operator itself was wrong, and hence kk broke from this loop. I don't need to do this again and again. I just break away from this loop, because the answer is decidedly wrong. Now, with this, we are in fact done. Like I said, the approach here is basically not new per se, but it's just a more systematic, more generalized version of what we have done in the class. If you go through this slowly, you'll find that the code is now quite scalable. You can have any number of operators, and you can actually make this game quite interesting. I hope you found this useful. Take care, and if you think this way of programming by learning activities, by doing fun activities, enhancing them is something that you enjoy, it makes you think better, do look at our website www.ybyte.in, because we have many, many, many such examples that you can learn from. Take care. Thank you so much.